Welcome back to part 2 of the Seplos 48 volt 230 amp hour DIY build. In this video we're going to be installing the front plate with all the bus bars and putting this battery into service. So if you remember from my last video, this battery did come without instructions. I reached out to the company, they did send me a PDF, and I was able to print out the instruction manual, which is going to be very helpful because I need to know certain torque values of certain components in this battery build. So if I can give one recommendation to the company so far out of this battery, have this in the packaging when you send it out. Also, another recommendation I have, allow the consumer to pick what size fuse they want to be shipped with their battery. This is a 400 amp fuse. This is going to protect the internals. It's not necessarily going to protect the wiring. This is more or less to protect the BMS and the bus bars that go to the battery itself. I'm using a 230 amp hour, 230 amp hour batteries. I would like to use a 200 amp fuse because I don't see me drawing more than 200 amp from this batteries. So just to have the flexibility to be able to pick what size fuse that you would like inside the battery would be kind of neat. The customer can install their own external fuse, which I do recommend, which I will be doing when I build my bigger system, but just different fuse size would be nice to be able to have that option. Okay, without further ado, let's start putting this portion of the battery together and turn the power on and see what it looks like. Okay, this is the back plate of the BMS. We have our screen display up here, our BMS, a shunt, and our B plus and our P plus for our battery connections. Now I'm just going to remove this wire for now to keep it out of my way. And let's turn to the instructions for what the connection looks like. We've already done those steps. Here we go. Okay, let's look to this page now. I'm going to want to look for a 3-hold one. That's going to be this one right here. So I'm going to install this one first. Now my method to putting this together is just basically process of elimination. So I'm going to go with the bus bars I can easily identify from the pictures. And if this is going to be going here, I'm probably going to want to install the fuse first. So this is going to be my fuse. Go ahead and remove the cover. Okay, we have a bolt and 2 washers. So I'm going to put one washer down. Again, I'm going to leave one washer. And the fuse goes on. And then I should be able to that will flatten out once it's tightened up. Let's see if there's a torque value for that. So 7 Newton meters, which is going to be 5.16 foot-pounds. So I bought a tool just to do this job. This is just a basic, really cheap torque wrench. That's all this is. And we have a 1/4 inch head on here. So I'm going to find a bit that's going to work with that. Okay, there's inch pounds. I can't really get... Let me try tightening it with the impact gun and then see what the torque is. Okay, let's see what kind of torque that gave. I don't know if I can even use this. It's easier with a socket. Yeah, I can't get my torque value with this Phillips head. This is going to be easier when I go to actually tighten up the terminal lugs for the battery. To get my actual torque, I can't do it with a Phillips head screwdriver. I'll just use my drill and impact down, and I'm sure it's going to be more than enough of torque on that. This next one is going to be put on like this. After I get these 2 bus bars on the BMS, then I will put my terminal posts in It just makes it easier to have this down flat and be able to screw it in with my gun. This is going to connect for the buzz bar, and it looks like, okay, so in the picture it actually shows it in a different orientation. So this goes like this, but if you can see it in the picture, it's coming up on this side of the shunt to get to the buzz bars here, and it looks like the screen in this picture is over here. So I have a different orientation. My screen's over here, and if I put this on this side, then it's gonna hit the terminal posts on the outside. So I need to change around the orientation comparative to the actual picture. Yep, that looks like it's gonna be the one. I've got all my bus bars on. I think I could put this one on too. How much was that? 61. There we go. See if I can get that on camera. And 61. And that's it. So these two are torqued. We're all tightened up. Okay, so next I'm going to put the buzz bars on for the front here. Now they are using a plug style. You can buy and use your own, which actually I might do. That's going to look quite nice. So we're going to have a positive, or a negative, sorry, and then we're going to have a positive. So that is going to look rather nice. I'm debating whether I should put my own connector just to make it easier so I'm not stuck using just the plug connector. I have them here. Let's see. My metal's a little bit thicker. It might work. Oh no. The threading in here to connect it, because I'm going to be connecting it to this bus bar. It might work. Let me see. Oh, the holes don't line up on the front plate. I'll wait for another day. Maybe I'll swap these out another day, but for now I'm going to stick to what came in the package. Okay, I'm going to continue on putting these in, and I'll be back once that's finished. Okay, I've got all the front pieces on here, except for the display cover. But I can turn to the back again, and we can see where these connections need to be made. So what that's doing is this is connecting these two negative posts together, and then this bus bar is going to connect to it, and there's going to be one source for two connections on the outside. Okay, we are good. And we are good. Okay, so these two are torqued. And that one is torqued. So now I can move over to the positive and do the same. Okay, check my torques on this guy. I can plug this back in here. So now we have the front plate on. So now before I make my final connections, I want to go through and check the torque value on all of the cells. We are going to need to be at 44.25 inch-pounds. So Go what looks to be 44.5. Okay, I have torqued down all of the buzz bars, the two final connections. So this is going to be my positive. And this one is going to be the negative. Okay, I'm going to make sure these are torqued. Okay. All right. Perfect. Now another very important step next. Now next what I'm going to want to do with this battery is I'm going to want to take a multimeter and test all the leads inside of the balance cables to make sure that they are appropriately organized here on the battery to actually in fact give a proper reading to the BMS. Probably can't see it. Put that on the negative bar. And the first black next to the white, so this should be, yeah, 3.3, and then it should go up roughly 3.3 every contactor I hit next. And that is going to be a temperature sensor. Temperature sensor, 16, 19.9, 23.3, and we're still going up 26. And that is going to be another temperature sensor and another temperature sensor. Now moving over to this one, should be two temperature sensors. Oh yeah, that's number 16. That's the top voltage, 53. So I'll start from the other end. Yeah, 29, 33, 36, 39. And that's got to be a temperature sensor, 43, 46, 49, 53, and temperature sensor. So right now our top voltage is 53.3, 53.2 volts. So we're good to go. Balance leads are all correctly identified and hooked up. Now one thing I should have done, which would have been a little bit difficult, is plug these cables into the case before I put it on, because I'm gonna have to try and get my hands down in there. Yeah, I'm not gonna be able to. And these buzz bars are flexible enough. I think I can pull this case back off enough and get the balance lead cables on. You know, a learning curve. And we just turned on and I've got the lid half off. Now we're back on track. Okay, so note to other people, test your leads and then unplug these, plug them into the case and then put the faceplate on and then plug them back into the PCB boards. All right, let's get the face screen on here and then I will show you what it looks like. Okay, I want to be super careful because I don't want my OCD to show later. That looks perfect. Okay, take the protective. And of course my inverter on my other battery that I'm filming decided to shoot on. I was at that critical moment. That's okay. Okay, and as you can see, we have the screen on. So we have a pack voltage of 53.32 volts, no current going in or out. Our state of charge, according to this, is 49.9. Now this will calibrate once I charge it up to full, then it'll hit the 100%. But let's see. Configure, nothing. Oh, there we go. Okay, cell voltage. Okay, our cell voltages all look good. Okay, our cell voltages are perfect. Let's exit out of here. And then our temperature. We are all looking good. Let's see if I can find temperature sensor number 1. Heat one of these up. Oh, we could see temperature number 4 starting to rise. So then I'm assuming that this is going to be temperature sensor number 1. Yep, that's warming up. Okay, so temperature sensors work. I really like this interface. So we have no protections on right now. We can see there's no protections, nothing like that. Let's go down to capacity. We have 200 amp hour rated. I can change that to 230. I don't think I can on this menu. No. So I can't change it on this menu, but I'll have to change that to 230 amp hour. And then our remaining is 99, almost 100 amp hours. What else do we have here? Okay, it looks like that's it for the menu. I really like this interface. And I really like that this is on the home screen. So this is showing on the home screen all the information you need. You don't have to hit enter and then search around and find. This is right on the home screen as soon as it fires up. And then as you can see here on the front, we have a capacity indicator, which I think once I start using it, these LEDs will light up. Have an alarm, a run that's flashing green, showing me I'm good. We have dip switches to put multiple batteries in parallel. Have our CAN/RS485 jack, another RS485 jack, and then a 485 jack, and a reset button. We do have a ground here. See if I can get that out. We do have a grounding screw here. Now it does look like the grounding screw is a little bit painted. I think once I run a screw in there, it's going to expose the metal enough to put a grounding lug on here. But it's only going to be contacting on the screw threads to the case. So not a very great grounding screw. Like as you can see on this battery down here, how we actually have a physical screw. We have a screw and we actually have a chunk of metal in order for a lug to sit against to ground that case. So a little lacking on the grounding portion of this case, but pretty solid case outside of that. Let's I want to put the cover on here, and then I'm going to put my shelf back on so I can put my inverter up top and hook this up to some power. Something to mention about this build too is that on the bottom there's feet that you can put on. I left them off because I want to keep this as low profile as possible, but the feet will run inside of these holes here for when you stack multiple batteries in order to keep them from falling off. So really neat design that they've done with that. It's just for my case use, I'm not going to use the feet on the bottom. I'm just going to have a shelf over top here, and yeah, so I didn't install them on this build, but there are feet that you can put on. And it helps if you're putting it on the ground, it'll keep it up off the ground. But I have it on a shelving system, so I'm not worried about any moisture or anything like that gathering underneath. I think I'm at the point now where I'm going to hook it up to the inverter. I'm going to need to get some more cables with these plugs, or I'm going to change out one of these terminal lugs. Come on, guys, did you really have to put all this on here? Okay, now before I make my negative connection, I have a 10-watt resistor, and this is going to allow current to slowly flow into this inverter, and it's going to save the capacitors inside of the unit. So all I do is basically hold it on the positive wire like that, and then hold this extra side here to the inverter. And we even had a little bit of a spark. It would have been a much larger spark if I wasn't using this resistor. And make sure we have enough energy in the capacitor and make our connection. Okay, we have our connections made now to the inverter. So let's fire it on. Oh, there we go. Now we can see the capacity lights on here. The capacity lights actually lit up on the front of the case now. Let's turn the screen on. We're currently drawing 1.11 amps. So that's the standby consumption. Now this is a low frequency inverter, so it does have a high standby consumption because there's a transformer inside that it needs to power in order to create a split phase 240 volt output. But let's connect it to power. I'm going to want to charge this battery all the way up to full. That way it's properly calibrated for 100%. And then I'm going to hook it up to my larger bank here after it's charged up, and I'll bring it down just a bit, connect it to the system, and then bring the whole system up so it's all balanced out at 100. And then probably take it down a little bit until I go to formally use the system. So let's throw the charger on and we'll see what happens on the display here. And I've got a little bit of current going in. There we go. Okay, we now have about 25 amps going into the battery. So I'm going to charge this up to full state of charge, and I'm going to check my cell voltages once it's charged up, see what they're sitting at. That's going to wrap it up for this video. We have the battery in service now. It's completely workable. Later on in the future, I'm going to have to do a firmware update on the BMS itself that came recommended from my comments section. Thank you very much for that. As well as I'm going to hook it up to a computer and see what the program looks like for the cells and balancing and everything else of that nature. So look forward to another video in the future for actually hooking up the computer to the BMS. Thank you for watching. If you enjoy this type of content, please subscribe and check out some of my other videos. Thanks for watching. Bye.